Welcome to the Neural Implant Podcast, where we talk with the people behind the current events and breakthroughs in brain implants in an understandable way, helping bring together various fields involved in neuroprosthetics. Here is your host, Laden Yuracek.
So we're here on the terrace of the public library here in San Diego, for the Neuroethics conference. And I really enjoyed your talk yesterday. You were talking about DBS and kind of the personality changes that comes along with that. And so that's been a huge point of contention that there's a huge change in personality. But you were saying, like, actually that's all overblown. So do you want to introduce yourself and talk about your research a little bit?
Yeah, sure. So my name is Frederic Gilbert. I'm currently based at the University of Tasmania, and my work mostly touch the putative effect of deep brain stimulation or brain-computer interface on patient identity, agency, and sense of the self. So I work in neuroethics, and yesterday, so you mentioned the talk that I've given. In that talk, I somehow analyzed the evidence that are used in the literature and the ethics literature the evidence that are used to demonstrate that deep brain stimulation actually cause personality change. And then we try to critically analyze that sort of data, and then we realize at the end of the day that's a bit more complex than just citing few study and quoting patient through papers.
And so yeah, I mean, this has been a very popular thing. Like, has it, like, ever since? I mean, deep brain stimulation has started like 20 years ago, something like that, right? And, and was that an issue right away, or did people start figuring it out later, or how did that
exactly.
work?
So it's a very interesting question. So exactly. So the first one thing that we have to say about deep brain stimulation, it's really safe, spectacularly effective. And so when it was first tested and implanted in human, scientists were able to observe that symptoms were quickly gone and the symptoms were under control. But it took a couple of years to realize that maybe something funny or je ne sais quoi was happening to some of the patients, to a minority of the patient. And they realized that, at least they report that some of the patients, despite being symptom-free, weren't better off after. Some, for instance, started to have depression. Some started to be apathic. And in worst case, they suddenly tried to commit suicide, for instance. But despite being symptom-free. And also, they report, so I'm referring to a study like Ajid or Shuba, report that up to 65% of their patients were divorcing or separating.
Oh, wow.
50% were stopping working despite being symptom-free and being able to work. So they try to investigate these phenomena and realize that actually it might be related to the technology itself. And from that moment, around 2006, 2002, Weto 2002, that we started to have a sort of a more ethical angle on the technology. So
Wow, that's incredible. Yeah, and you were talking about addiction, gluttony. So, I don't know if it was they were talking about this, and so basically it's almost like you can't control yourself, like you just become a huge addict. Or how would you describe it? Is there like a general pathology or something?
No, actually, the subtlety with DBS is that it is currently used in different pathologies, and each pathology require a specific perspective to understand. So, for instance, if you have Parkinson, with or without the device, you are more likely to develop some psychiatric side effect because of the disease itself, right? And if you have the stimulation on, it might actually decompensate it. So this is what we have learned from Weto back in 2002. We know that since 2002 that if you have an history of psychiatric condition, you should not be, in relation with Parkinson, the dementia Parkinson, for instance, you're better not having the device in your brain, actually. Because it's so effective that it unmasks the adverse or the psychiatric condition, if you will. So, but that's something quite distinct from someone having depression, for instance, or OECD. But just for the viewers, so currently Parkinson's disease, dystonia, and severe tremor are the only authorized type are the pathology where you can use deep brain stimulation. All the rest are used on a humanitarian exemption or experimental trials. So if you think about DBS for depression, obsessive compulsive disorder, Tourette syndrome, obesity, dementia, and epilepsy. All of these trials are still experimental. But again, just to jump back on the first point, is that if you put that in the brain of someone with depression, you might trigger some adverse effect that you will not necessarily find in someone with Parkinson's disease, because the area where you're targeting are quite distinct, actually. And that might trigger other adverse effects, for instance.
So, interesting. So, okay, so they were starting to find this out, and then what happened? Like people started raising the alarms, and what I want to get to, you did the meta-analysis with the 1,100 papers, and then a very few were actually like direct.
Yeah, exactly. And so what we have realized is that, just to answer your question, so when these publications were out there, of course you have then the people like me, neuroethicians, that are a bit puzzled, and we have to investigate more, and then that's how basically my work fit under that. But there has been a sort of exaggeration, if I may say, from ethics, for the good reason, I would say, because we want to protect patients, we want to be sure that they are well informed before putting that in their head. Where we talk about the potential effect or the putative effect. So if we say that, that it might impact agency, that might impact identity, it is often a bit extrapolated out of a little bit of evidence. Because if you clearly look at the seminal work from Weto, Ajit, and Schubert, they're not concluding that DBS cause in itself, by himself, alone, personality change. No one is concluding that at all. But these papers are being used by neuroethicists as evidence that DBS caused personality change. But again, that doesn't mean that these conceptual work are not important. This is very important. But we have to be a bit careful in how we are articulating our hypothesis here. And this is the reason why we need more work regarding these potential risk. Actually, we need to know more.
And so, what percentage of papers were actually based on actual patient data, like first-hand data?
So we were able to capture 1,534 articles searching from deep brain stimulation, personality, identity, agency, authenticity, and autonomy, and self. These were the key words. So PIAAS. 1,534 articles, and out of these, only 64 did actually include first-hand patient studies.
So it's like 5%.
Something like that. But even if it's getting worse, because when you look at the 64 study and trying to see if they conclude that DBS caused directly or by itself personality change, it is only 8 of them actually that will lead to potentially saying that it could be. That includes studies like Ajit and Schubert and Weto, who do not at all conclude that DBS caused personality change. But if you read the report or the experience of the patient, you can actually think that it might be the case. But again, this is we cannot summarize the complexity of the panel yesterday. But when we think about, if you ask me, does DBS cause personality change? So I guess my answer would be, what do you mean by deep brain stimulation? Are you only mean the stimulation? Do you mean that because you're introducing electrode that might cause a form of lesioning? Is it because both of these variable? Is it also because the patient will stop using medication, which is itself, impact a lot of behaviors? Is it because they might indirectly touch the dynamics of their families or their partner? So if you have Parkinson for 20 years and suddenly it's gone, and your partner being somehow your carer, that will impact your family, that will impact their lives. So,
like they're not needed anymore, right?
For instance, that's why we have seen these high rates of divorce, for instance, for the French one. But these numbers haven't been replicated so far. These were very high numbers. There's still a case of separation, divorce, but not as high as 65, actually.
Wow. And so, I mean, it is possible to actually tease out the variables. So when it's on versus off, how they're feeling, and then the surgery and just the relationship thing. Do you know any of these numbers? Any intuition?
There's actually also the interesting element is that none of these studies that apparently demonstrated that deep brain stimulation may cause personality change, none of them include control group. Actually, there's only one major study conducted that include control group. That's the one published by Gilbert.
And what would be a control group actually in this case?
Would be some patient with the device not stimulated and then stimulated, but none of the clinician of the group knows it.
Okay.
And the Gilbert paper published in the New England Journal of Medicine in 2013 indicated that those who were not stimulated were more likely to develop psychiatric side effects actually than those stimulated. So that seems to indicate that if the side effect might not be because of DBS, might be because of the pathology itself. And again, this is what it's tricky with Parkinson, is that with or without medication or implantation are more likely to develop psychiatric condition in the long term. Yeah, but it's 40%, 37, depending on the study.
And so how many DBS patients are there, and then how many have been studied?
Right, so this one is not very clear. Nobody really knows. So Medtronic is the biggest manufacturer of the device on the planet at the moment. They report that there's about 150,000 of their devices implanted. Mostly, the overall majority of patients are patients with Parkinson's diseases. But there's 21 companies currently that are manufacturing DBS. And they do not only implant in Parkinson's, and so and that includes a new company from China. They are pretty aggressive at the moment. They are actually helping to conduct experimental trial on patients suffering from addiction. So a rough approximation. Yeah.
Wait.
Yeah.
So they're trying to cure addiction, and they've been showing that this increases addiction.
No, actually, I'm sorry. I've spoken too fast. So no, they help. Like here also in North America, the industry helped to finance some of the research. So in China also, they have these new companies that are helping, I would say, aggressively to advance the science of addiction. But they have mixed results, and but that might be another topic.
Yeah.
But so just to answer your question, so we don't really know the number. In a rough approximation would be like something like 200,000 patients at the moment having deep brain stimulation with open loop. So closed loop that would probably change. That's the promise.
And how many have been studied in this way, or how many have been psychologically reported? Yeah, exactly.
I can't answer this question. I don't know. No, I think that would be a minority.
You were saying like 150 or something, wasn't it? Or what was that number? Of that 200,000. Do you guys only talk? We've only talked to 150, something like that.
No, yeah. From the meta review that we did, that did include about 168.
168,
but not all of them would have qualified or manifested personality change. That's why statistically this is insignificant. But again, this is not evidence that there's no risk. Yeah. The absence of evidence doesn't mean that it is evidence of an absence.
Okay.
And I personally have spoken with and seen and interacted with the patient that have clearly the phenomenology of something a challenge following the implantation and the stimulation. So I'm not denying that. I'm just simply that statistically we have to be careful because in most cases it worked fine actually. And, but again, neuroethics work is fundamentally important, essential, because specifically when we want to advance these neural devices, if these devices are not ethically acceptable, they won't last in the long term. So that's why it's very important to ensure that patients are well protected and that they're well informed also.
Yeah, actually, that kind of goes good with my next question. Like, what is neuroethics? And I mean, you said like we need this in order. I guess for the entire field to survive, we need neuroethicists to make sure that like the government or something outside doesn't kill it. But I don't know, like, what is neuroethics, and what do you do?
The classic definition by Adina Roski is that neuroethics is the ethics of the neuroscience, and vice versa, the neuroscience of ethics. So here, I guess, during the conference, you have seen more the ethics of neuroscience rather than the opposite. But basically, it's the fundamental questions that are not necessarily explored by neuroscientists, not because they're not interested, because there's something their funding does not allow them to look. And that includes safety of patients that are on the front line actually of the development of these technologies, and that often in relation with the FDA, for instance, how they can regulate devices, how we can articulate some protocols. And again, it's the ethics is not there to slow down or to stop the advances. It's rather to a very good friend that you want to be sure to ask questions to be sure that your technology actually will promote the best possible outcome for patient. And I guess with brain implant, even if you have the best technology, even if all the symptoms are addressed, it doesn't mean that patient will be better off after. This is what we learned with DBS, is that some patients, even without their symptom, they're getting worse actually. And these questions are often more a matter of philosophers have more time, I would say, to explore these questions than the neuroscientists.
And so, I guess, what do you do too? Like, is it so? So this is the thing that struck me about that. 1,100 papers, and of that, only 60 were like primary source. Yeah. Is it mostly people like sitting down and philosophizing, writing essays about what they think, or what portion maybe do you like actually go into a clinic and talk to people? And
but that's actually it's a very good. Excellent question, because there's a sort of cleavage between, if you're not a neuroscientist, sometimes you cannot really easily access the labs. So my training is philosophy. I have a PhD in philosophy, but it took me a while before being able to be accepted within the lab, and you need to establish a trust. And often neuroethicists are perceived as a potential threat to science, because some scientists have the stereotype that it might just slow down or stop their research, and again, it's not at all the case. It's quite the opposite, actually. And just to answer your question, so the papers that we were able to read, they were mostly clinical reports. A lot of them were anecdotal reports or single case reports. So I myself have published many single case reports of some patient experiencing, I would clearly say, personality changes. But that can't establish a causality link, because there are anecdotal observation. Yes, it's a form of evidence, but that can establish a causality, because it's one case among that 100,000. And but these if we jump back, one of the first elements I mentioned is, if you think about what is DBS, there's a lot of invisible effect that you can't perceive directly with stimulation or implantation, and all this sort of way of how one would be behaving within their network, with their families. That is essentially very important to ensure that the technology works fine for the patient, but also for the families, actually, and society.
Interesting. And so a lot of neuroethicists, is it mostly in academia, or is it in industry as well, or where are they mostly employed, I guess?
Mostly in academia at the moment. There's a little bit of interest from the industry, so I myself being approached by some companies, but it's a slow process. And specifically when you know well, because you work on within the field of neural implants, it's sort of cutting edge technology. So the ethics, unfortunately, is often a bit late. Ethics rarely is in front of the race. It's always trying to catch up. So I would say private company are interested into us, but they should take advantage of people like neuroethicists to again help them to articulate their end goals, and also be sure that end users are well represented and protected within their experimental phases, for instance.
It's kind of an insurance up front, something like this, make sure something worse doesn't happen later on.
Exactly, because if you look at I would say the garbage bins of science, you will see many promising science technologies that actually would have accomplished a lot, but they never very secure safety, efficacy, or protection of potential patient, and therefore they were abandoned very quickly. And it's something that with neural implant, there's so much great benefit out of it. We want to be sure that patient and user are well protected.
Yeah, very cool. Very cool. Yeah, this has been very interesting. And you're in University of Tasmania,
at the moment,
south of Australia. This is
exactly.
This is interesting. I haven't heard anything. I didn't
aside from the Tasmanian devil. I also have an appointment with a University of Washington. But physically not in Tasmania. We work with a set of universities that are developing electromaterial, mostly And we work with, the cochlear implant was invented down there, and Brian Clark. So I'm working closely with Mark Cook, who is the director of the Brian Clark Institute. And Brian Clark is still around, actually. So they tried to develop a better new generation of cochlear implant, but also other type of stimulator, brain-computer interface that can predict epilepsy, for instance. And again, that's also a very promising field, actually.
Interesting. And so do you only do DBS, or do you have other research interests as well?
A brain-computer interface, what we call the advisory device. So it's an AI system that is personally developed for you and is trained to specifically target some neuronal activity, like epilepsy. So it can predict forecast it ahead. Sorry. And when it predicts it, it informs the patient, and the patient can take medication. But we were spending time with the patient because we're trying to understand what type of relationship they are developing with a device that is smarter than us in a way, or know better. Because at the moment, these what we call closed-loop device are being tested for OCD, Tourette, depression. And they won't stop there, actually. So the principle is pretty easy. So if you train a machine learning to detect specific event in your brain, they will know it before you and inform you. Some way they know it better. But some patients, that we have realized, are not coping well with that, actually. We have finished 2 papers on that very phenomenon. Some patients have experienced a form of estrangement, where they have suffered from some rupture in identity. Because, long story short, the patient felt that they were only epileptic part-time, only when it was manifesting. But with the device, they were constantly reminded that, the device was telling them ahead, and they had to decide. So, and they weren't ready for that, and psychology that did impact their life, and they did develop some depressive symptoms following that. And again, you had the best technology, but it wasn't well accepted by the end user, and they weren't prepared for that. So that's where the ethics is very important, that you have to prepare not only the patient, their families, relatives about these potential effects.
So the ethics of that wouldn't be to stop it or anything like that. It would just be to warn the patient and be like, okay, this might happen, and something like this. Is that
exactly?
Okay.
And actually, there's a French study published last year. My jet lag doesn't help me to remember the title.
What time is it for you right now?
It's 7 a.m.
7 a.m. Yeah.
Like 2 days, I haven't really slept. So and they have shown that if you do not prepare patients, they test the hypothesis. Some patients in the control group were prepared to the potential side effect of DBS, and the other group weren't prepared. And they have realized that those who weren't not prepared had more difficulty to adapt with the device and the families. So it seems to indicate that they really need to understand clearly that there's a potentiality, that there's or the risk, and that is something that should bring expand to other technology like brain-computer interface, brain-machine interfaces. And we also work with some patients paralyzed, also that regain function, also how they interact with the device. Because again, this is just it's a sort of a booming field now, and that would increase.
So your work is more like implanted, like not
invasive technologies,
EEG or something like
exactly,
this. Implanted stuff.
Invasive brain technologies.
Interesting. And so what about the paralyzed patients? What are some issues there?
At the moment, it's very spectacular to see someone paralyzed regaining function, and so currently, what we can say at the moment, there's a little bit of issue with the false positive. For instance, if they want to do X, but the computer do Y, so we will call it false positive. So in the lab, it's okay, but if the technology is out there and you want to cut a carrot, but instead you cut your finger, but I wasn't thinking about the finger. It's okay, it's on you, but then you can imagine many scenarios where there's a false positive can actually result in a damage or hurting someone, or worst case scenario, fatality. So there's a raised question about responsibilities, but we're not there yet. But that does show that we have to spend more time on these false positives, actually.
Wow, fascinating stuff. Is there anything that we didn't cover that you want to mention?
No, it's no, but it's very interesting, and I think we had a nice conference. It's still going, but. Thank you for your time and
thank you as well.
The interest in the research in neuroethics. Thank you very much.
Thank you.
Thanks.
Hope you enjoyed the show and were able to learn something new, bringing together different fields in novel ways. Until next time on the Neural Implant Podcast.